16. Okay, so for naming compounds, so I'm assuming that you're going to want to go over naming mostly ionic compounds, or also some covalent compounds, or what?
We're doing everything. My main question is, like, when you have, like, on the periodic table, how do you know how many neutrons, protons, and electrons there are? And if they give you something like this many protons, how do you know how many neutrons, or, you know, like neutrons and electrons are there?
Okay, so let's say, for example, we have oxygen right here. Now, if we look at oxygen, it shows that up here we have an 8, and at the bottom we have approximately 16. It says 15.99999, like that. Okay? So this number right up here is the atomic number, but it's also the number of protons. Okay? So that number is the number of protons, and this number right here is called the atomic mass. Oh, and we got data. Awesome. So this number right here is called the atomic mass, and it's a combination of both protons and neutrons. Okay? The number of electrons will actually be equal to the number of protons in a perfectly balanced atom. Okay? Atoms, for the most part, will have the same number of protons as neutrons because they like to be neutral. I mean, protons and electrons, sorry. Protons and electrons will be similar. Protons and neutrons, however, can be different. Like you'll see with some of the smaller atoms, they'll actually have similar numbers. Like, for example, a proton and an electron, no, a proton and a neutron will weigh the same. So, if we take this number right here, which is the combined mass of both the protons and the neutrons, we can say, okay, so we got about 16 there. So 16 minus 8 gives us 8. So we have 8 neutrons.
Okay.
Okay. And that's the way that you can find out how many neutrons you have. You just multiply, or you just subtract your number of protons from the atomic mass, and you'll be able to find out how many neutrons you have.
Now it makes sense. I have protons plus electrons, so that's what's throwing me off.
And then another thing about the periodic table. So you're going to have this funny looking thing. Okay. And so, let's see. We have 8, 7, 6, 5, 4, 3. Okay. So 8, 7, 6, 5, 4, 3. Perfect. So this is group 8. This is group 1, 2, 3, 4, 5, 6, 7, 8. And with charges, when you're dealing with ionic compounds, you'll actually be able to use the periodic table to figure out what's the charge of each ion that you're using, for the most part.
The cations and the anions.
So this first group always has a charge of positive 1. This group right here, positive 2. This group right here, positive 3. Group number 4, we don't really use so much with ionic compounds. Okay? Most of these guys over here are used in covalent compounds, but we also use them for ionic compounds as the anion. Okay? So this guy right here, so this is group number 4, we don't really use it. Group number 5, I'll have a negative 3. Group number 6 will have a negative 2. Group number 7 will have a negative 1. And group number 8 is neutral all by itself. It's a noble gas. It doesn't really form compounds with anything. Okay? So if you'll notice, with these guys, you'll later learn about the octet rule, but with these guys, these two numbers will add up to what number? 8. That's because these guys all want to have 8 electrons. Okay, that's the whole reason why they steal electrons from these guys. These guys have these many electrons, and they have basically, like this one has 7 empty spaces, this one has 6 empty spaces, this one has 5 empty spaces. And it's saying, well, I don't want it to have so much empty space, so I'll just get rid of these electrons so I don't have to worry about the space. So that's why they lose electrons. They lose negative charges and they become positive. And these guys, they're very willing to gain electrons because they don't need that many electrons. They have more electrons, so they don't care if they get a couple more.
Okay.
So they want to get a couple more. And then, so do you know the difference between cation and anion? Okay.
No.
So yeah, just a trick. Cation has a positive sign in the middle. Anion stands for A negative ion.
Oh.
That's interesting.
So just two tricks right there. But yeah, cations will usually always be metal. There are some exceptions, very few exceptions. One, for example, is a polyatomic ion. It's called ammonium. Okay, ammonium looks like that. It doesn't have any metal in it, but because of its structure, because of the way that it's formed, it actually looks like a molecule. It is a molecule, but it has a charge overall, which makes it an ion. So it can be a molecule and an ion.